Okay, so now we can try doing the add. So let's loop through, and actually we want to do this stuff, this adding to the hash table, we want to do in this function here, in this gen content function. So now we're not going from 0 anymore, we're going from args start, and then we're doing the count, so it's going to be args start plus args count. And yeah, and that should get that properly. Although we are missing the table, so we need to add the table to our arguments here. So struct. Now, I think it's really good to think about exactly what should be passed here. Let you think about that for a second. But since this is already getting kind of long, I'm just going to jump to the chase. We need to pass the table by pointer because all of the threads need to be working with exactly the same table. So we will pass it by pointer there. So this table, and this will be the address of the table already in args. So we can just say args table. And that should add to the table. And then let's see, the table initialization we need to do up here at the top. And right, and then we can print the buckets. So let's see what happens when we run this. Badness. Seg fault. We can try running again. You know, it's quite possible that you might get this to run properly one time, but actually we're getting seg faults because we have multiple threads accessing this table, and it's getting corrupted. So of course the answer to this is to add a mutex. So let's add a mutex to the table. Let's see. So we can add a pthread mutex. Call it the lock. And then we need to initialize that lock down here. So after we initialize the heads, we'll say pthread mutex, whoops, knit, and then table lock. Let's see, does this, yeah, and we'll go with the default mutex. Oh, and we need to pass that by address. Okay, and then whenever we do anything with the table, when we do the add to hash table, we are going to take the lock. So we're going to say pthread mutex and table lock. Now, why are we putting the lock here and not before the hash? So hopefully that is clear to you. If it's not, think about it for a bit and see if you can figure out why we don't need to put a hash in the lock. Let's run it. Oh, we are still getting a crash. Let's see. Why are we still getting a crash? Actually, let's run it under the debugger and see exactly where we're crashing. Oh, we're crashing on the lock. Oh, because the table is null. Oh, because we didn't set the table right here. Whoops. We needed to pass the table here. So yeah, that should fix that null. Let's run it one more time. And that worked. So here we should probably see very similar behavior with like really big bags. Yep. Okay, this works. Actually, since the problem wasn't with the thread safety, it's that we are passing a null table. Let us just comment out this lock just to see what problems we would have if we didn't lock it. Okay, so it looks like things kind of worked. Actually, it looks like everything worked properly without the lock. So let's look at something really quick. So we can run, whoops, let's run this from the terminal. And oh, first let's time it. So, oh, we see the time hasn't changed. It looks like it might have gone down a little bit. Yeah, it has gone down a little bit. But let's count the number of lines. So there's the word count with the number of lines. So that's 10,000 lines plus 234. Actually, that is not right. And actually, as we run it, we see that we're not getting enough lines out. So our hash table is dropping stuff. Okay, and it's dropping stuff probably because it's not thread safe. So let's put the lock back in, run it. Okay, and we'll count the number of lines. And here, this is what we expect. So there's 10,000 of the node lines, and then 256 of the dash 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 lines. So this is correct, and we'll see that as we run it multiple times, it's stable. Let's time it. So when we time it, we see it's 3.8, so it's gotten a little bit slower. Oh, yeah, so actually it's a little bit faster. It's not too bad. So let's see if perhaps we can do better. Now, if we look at our lock, we're locking on the hash table. But remember when we talked about hash tables, we could do finer granular locks. So rather than having a lock over the whole table, we could actually have a lock on each bucket. Okay, so we create a lock on each bucket. Let's see. Now when we initialize here, we're going to need to go through and say I equals 0, I equals some bucket count. Okay. And this will be indexed by I. Okay, so and then when we take the lock, I just gotta make sure. Oh yeah, so we're gonna take the lock of the bucket of H. Whoops. Okay, let's run it. Whoops, let's run it and see if it works. Okay, that looks good so far. Let's make sure we have all the lines. Perfect, we have all the lines. See how long it takes to run. So yeah, actually, we don't really see very much improvement. I have a feeling it's because of the time it takes to print out those lines, because that takes a bit. So let's send that to dev-null. So basically, ignore the output. So this makes it run much faster. Here we see it's taken about 0.6 to 0.9 seconds, 0.09 seconds, or 0.009 seconds. Let's put the big lock back in. So we'll take this out, take this out. We want to do the big lock. Okay, and oh, we can just do this. P big lock. And So here, table big lock. Okay, so up here, so instead of locking on, yeah, so we're going to lock on the big lock here. See if that changes anything for our running time. Let's see, it works. Okay, good. Let's see. So here we see it does, I don't know, it does run maybe a little bit longer. We see the system time here is kind of going up. So that system call is where we're acquiring the locks, or we're getting the lock contention. So we're about 15 seconds. Oh, 7 to 9 to 15. Let's change back to the other locks. So this is lock H. We do the fine grain lock. Let's see, do we, yeah, so we need to initialize those. Okay, let's run it again. Okay, and here we go. Yeah, so we see it's kind of consistently faster. So it looks like it's about, oh, that one was slower, but it's around 0.008 seconds. So the finer granular locks do help us. Now, because the entries aren't evenly distributed, as we see here, we are going to get just natural collisions because we have these buckets that are very full of nodes. Okay, so now we have our thread-safe hash table.